Welcome back. Today we're doing 11, container with most water. You're given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I0 and I height to that index I. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice you may not slant the container. Okay, so let's look at example one, right? There's two locations that they've chosen to be the heights here. So input is height, and these are some heights, and the output is 49. Now the above vertical lines are represented in the array. In this case, the maximum area of water the container can contain is 49. And what does that mean? That means here it's of height 8. This red line right here on the right side, it's of height 7, and it's some distance away, right? 1, 2, 3, 4, 5, 6, 7. 7 away. And because the container can't go to 8, it's going to take the minimum of the two, 7. 7 times 7 is 49. Now, how did we come up with this answer? And honestly, I don't know how to explain how this answer is arrived upon. I think it just comes down to trying some examples and getting some intuition. But if you get this problem in an interview and you've never done it before, I suspect it will actually be very hard to do it. So let's consider what the question is asking of us, right? We have some heights, and the heights have some height to it. And what we care about is the left, let's say, height that we're going to choose and the right height that we're going to choose, right? This is going to create some type of square, and that square is going to represent an area of water, right? Let's say this is represented by indices, and let's just think through the mechanics. We're going to have this right one and this left one of index 8 and 1, right? 8 minus 1 equals 7. Is that 7 away? 1, 2, 3, 4, 5, 6, 7. It's 7 away. And the minimum of these two heights is, let's say this is 10 and this is 5, for example, right? So it'll be 10 minus 5, or sorry, the minimum of 10 and 5. And that's going to be 5 multiplied by 7, which is 35. So that's just the mechanics of it. How do we go about choosing this left and this right? Well, I don't. So let me tell you the answer, and we can try to figure out backwards, I guess. One thing we can do is start the left and the right on the extremes, right? Here at index 0 and at index 11 here. And what we can trust is that the further it goes, the more width this has, and hopefully that width increases the area. Now, what that depends on is the actual height of these bars, these heights, right? So, let's say our goal is to move the left pointer and move the right pointer, ensuring that we have the maximum area. Now, what can affect this situation? Imagine if we had different heights. We had this of height 1, we had this of height 2, we had this of height 3, this of height 4, this of height 5, and let's say super 1, this of height 10, and this was our left and right, right? And this was our input. Now, no matter what, we have at least the extremes where the minimum represents some type of area, right? Here it's 5 minus 0 would be the width, right? And the height, the minimum height would be minimum of 1 and 10, so the area would be 5, right? Now, we see that this is monotonically increasing which one should we move? Should we move left or should we move right? Let's think about it. Let's say we moved right. If we moved right, well, the minimum height is now of 1 and 5, right? The width is now 4, so that's going to get us 4 times 1, 4, right? What if we moved left? Well, width is 4, but now it's going to be minimum of 2 and 10, and that's going to get us an area of 8, right? So this one's actually better. Okay, well, what decision did we make when moving left and right? What decision can we make? One decision we can make is that at the value of left and the value of right, the heights, if one is smaller, then we move that one. 1 is smaller than 10, we move this. 2 is smaller than 10, we move this. 3 is smaller than 10, we move this. 4 is smaller than 10, 5 is smaller than 10. Because 10 is some type of upper bound, and we want to move up the minimum, right? The minimum, like how we moved from 1 to 2, we want to move the minimum to a higher number. Now, does that always work? Can we fall into a trap? Let's say there was a 1 here, there's a 10 here, and you know, let's say there's like 1,000 here, right? Well, what do we want in this case, right? Let's say this is 2, this is 3, this is 4, this is 5. Well, do we want to move the left or do we want to move the right? Well, if we move the right, we'll go from this 10 to this 1,000. And the 1,000 is very attractive. 1,000 is very tall. However, we don't increase our height because it's still taking the minimum of 1 in 1,000. So we actually, instead of going to that 1,000, we want this L to go to the 2, to go to the 3, to the 4, to the 5. Now here's the interesting point. What would be best is, so let's look at these, right? What has more area? This one or this one? Which one do we want to move? We want to move the L to this 1,000. So our rule still stands. If it's a smaller value, we move that value. So, you know, that's why I don't really particularly like this problem. It's kind of a trivia problem because you might get stuck up trying to figure out some counter case where this isn't true. Where when you want to try to figure out, okay, what if this 5, I don't know, had a 2,000 here, right? Then we move the L to the 5, and then the R moves, so the R, because 10 is smaller than the 2,000, it moves to the 1,000. So now we have this guy. Well, that's exactly what we want. Okay, so what if we try to trap it? So I don't like this problem mostly because if you think too hard about it, you can get trapped. When the general rule is like whatever height you're on, if it's smaller than the other height, let's just move that height. And trust that in the iteration it blows through all traps. All right, so that's this problem. So left equals 0, height equals length of the height minus 1, and while the left smaller than or equal to right, Actually, it could just be smaller, because if it's the same number, you'd imagine that's a width of 0. Then let's keep a sense of what the max area seen is, right? It's max area seen, or just max area. And we'll make that, we can make that 0 for now. And we want to return max area. And, val height left is height at this left. Height right is height at this right. Okay. And then what's the current area? So the current width is right minus left. Right, so as an example, we have the 0 to 5 here. 5 minus 0 is 5. And we want to ensure this is 1, 2, 3, 4, 5. 5 width, right? So that's the width. And what is the height? Well, the height to be used is that min height, right? Height of it. So I'll just call it the area height is the minimum of the height at the left and the height at the right, right? It's the minimum. So what is the area? It's going to be the width, right? You can call it area width if it's confusing. Area width times area height, and then max area. Let's set it to whatever max area is, or an area that is larger. Okay, so we have right and left here. And what is our iteration? What is our decision point? When do we move these? So if the height of the left is smaller than the height of the right, then let's move left. Else it's a tiebreaker. A tiebreaker, you can take either one, but let's move either one of them. Right minus equal 1. Okay, so what we're doing is we're getting the heights here. We're calculating an area, resetting the area if needed, making that decision point. If it's smaller than that one, we'll move one of them, and hopefully that gets us our area. Awesome. Thanks a lot. This was, I'm not sure what to learn about this problem. I think it's just learning how to use two-pointer and getting a sense of a general rule here. And then also, in a real interview, you could spend a ton of time thinking of edge cases if there's a problem of significant difficulty, but in my experience, you're not going to get some type of 1 in 1 million edge case in most interviews. So keep an eye on time and make sure you give yourself plenty of buffer, because typically if you do get a console and some test cases, you can run this against a test case, and that could be your source of truth. Anyway, thanks a lot. I will see you on the next one.